Hi everyone. I'm going to, as promised, talk about what happens when we add the two-place predicate identity to the language PL. This is in the last section of chapter 7. Okay, so let's think about this. What color do we have in our, good. So suppose, that's not what I want. So let's take a look at that quantifier. So we read that means there is at least one x. Right? So for instance, if I said, there exists an x, cx and fx, where cx means is a cat, and fx means x is finicky, then what this means under that dictionary is there is at least one finicky cat. Okay, we know that. How would we say there are at least two finicky cats? How would we say that? Well, it turns out we need identity in order to do that. Because if we just did this, there exists an x, there exists a y, x is a cat, and y is a cat, and x is finicky, and y is finicky. If we just had that, this doesn't rule out the possibility of x and y sort of talking about the same thing, so to speak. So in order to ensure that we are saying there are at least two, we need to use identity. So what we're going to do is we're going to add this two-place predicate identity to our language. And so we're going to have, and furthermore, x and y are different. It's not the case that x is identical with y. And we have to put that in because using different variables doesn't necessarily commit us to there being more than one finicky cat. Now, I want to say just a word about the syntax here. Identity, which we use this sign to refer to, we're adding that as a two-place predicate to our language. And its meaning is fixed. We know what it means. It means it's the same thing as. But in terms of the, excuse me, the syntax of this, all of our other two-place predicates, like hxy, lxy, or whatever, we put the two-place predicates in front of the two individual terms, right? HRJ, Romeo is the husband of Juliet. Well, they never got married, did they? Let's change that to loves. Accuracy. So this is actually an atomic sentence of PL. And note that we always put the two individual terms after the two-place predicate. The predicate prefixes them. But with identity, we put the two-place predicate, put the identity sign, which is a two-place predicate, in between. I mean, we could do this, and that could mean that A is identical with B. But we do this instead. Okay, so it's the only two-place predicate that we put in between the two individual terms rather than prefixing it to the two individual terms. Moreover, what I've got here, it's not the case that x and y are identical. The negation sign, if you think about the way that we build up formulas of PL, this is a formula. In fact, this is an an atomic formula. It's actually an atomic sentence. And so we can stick a negation sign in front of it. So this is well-formed. This is a well-formed formula of PL with identity. So we keep PL with identity. It's just PL, the only thing we're changing is we're adding this two-place predicate whose meaning we already know. Okay, so I just wanted to make that clear that syntactically there's something different going on here with this two-place predicate. And the negation sign attaches to the identity. It's not attaching to a name or a variable. It doesn't make any sense. You can't negate a name. You can't negate a variable. You're negating the formula. Okay, so that was my little syntactic note. But that's how we can say there are at least two finicky cats. There's X and Y. X is a cat, Y is a cat. X is finicky, Y is finicky. And they're different guys. They're different from one another. Okay, let's take a look at another one. We can say all kinds of things now with identity in our language that we couldn't say before. So, all the girls in the class except Charlotte have a pierced eyebrow. All the girls in the class except Charlotte have a pierced eyebrow. Well, how would we translate that? So we're going to have, let's let our universe of discourse be girls in the class. And let's let C be the constant for Charlotte. She's a girl in the class. And let's have P, the one-place predicate P, as has a pierced eyebrow. So how do we translate that? Well, first of all, it's clear that Charlotte does not have a pierced eyebrow, right? It's not the case that Charlotte has a pierced eyebrow. And furthermore, what do we want to have as our second conjunct? Everybody in the class who's different from Charlotte, right? Everyone who is not Charlotte does have a pierced eyebrow. We know how to say that. It's going to be an A-ish kind of sentence, right? Everybody who is not Charlotte, right? It's going to be an A-ish sentence, A-ish kind of sentence. That's what I just circled as the antecedent condition. And then this is the consequent position. So that's going to be for all X. And remember, our universe of discourse is girls in the class. So given any girl in the class who's different from Charlotte, it's not the case that X is identical with Charlotte, then that girl has a pierced eyebrow. So the whole thing becomes that. And that's how we translate that sentence. Okay, that's kind of cool. We couldn't do that without identity, in case you ever wanted to translate that into PL. Okay, well, let's continue, get things a little bit more complicated. How would we say, so we know how to say, we knew how to say there's at least one finicky cat, and we know how to say there are at least two finicky cats. How would we say there's exactly one finicky cat? There's one and only one finicky cat in the world. Okay, well, that's going to be an existential claim, right? You're asserting the existence of something that is the sole finicky cat. So we know how to say there's at least one. So that's how we say there's at least one finicky cat, right? But now we want to say He's the only one. There's no other. And here's how you do that. So there's something in the universe that's a cat and finicky. And what we want to add to that is, if you run into a finicky cat, right, I need a new variable here, right? If you run into a finicky cat, anything you run into that's a finicky cat, you think it's another finicky cat? You're wrong. It's the same guy. So that's how we say it. This part here says there's at least one. So think about what we mean when we say there's exactly one. We need to say there's at least one. And what this says is it's the only one. There's at most one. Because this says, okay, so given any finicky cat that you run into, oh, nope, turns out it's the same guy. It's that finicky cat that we already talked about. So that's how we assert the existence of a unique finicky cat. Okay, all kinds of stuff we can say, right? Here's one more example. How would we say, go back to Charlotte's class, there are exactly 2 girls in the class who have pierced eyebrows. We want to say there are exactly 2 of them. Okay. Well, we know how to say there are at least 2. Right? We did that with the finicky cat, right? We know how to say, where were we? We know how to say there are at least 2 finicky cats, right? We say that, you know, this guy's a finicky cat, that guy's a finicky cat, and they're different from one another. Okay, so to say that there are exactly 2 girls in the class who have pierced eyebrows, you want to say there are at least 2. And there are at most 2. Right? You have to say both those, at least 2 and at most 2. You have to say both those things. And if you assert both those things, then you've got, there's exactly 2. Okay? Because you want to say there are at least 2, and they're the only one. So we know how to say there's at least 2, right? We'd say there's X and there's Y. And remember, the universal discourse is girls in the class, right? And X has a pierced eyebrow, and Y has a pierced eyebrow, and they're different from one another. And by the way, so once again, I don't need any parentheses around this identity formula, because if you think about the formation rules for PL, you just stick. If you've got something that's a formula, which this is, then you can stick a negation sign in front of it, which is exactly what we do. So you don't need parentheses there. Okay, so that's how you would say there are at least 2, right? There's X and Y, they have pierced eyebrows, and they're different from one another. Okay, and now you want to add to that they're the only ones. They're the only ones. Okay. So what you need to add to it is, okay, and by the way, if you run into a girl in the class who has a pierced eyebrow, no matter what girl in the class you run into who has a pierced eyebrow, what do you know? Well, you know that that girl is either X or Y. So what we have to add to that is an A-ish kind of sentence, introducing another variable. So if you run into somebody who's got a pierced eyebrow, then this sentence guarantees that that girl is either X or that girl is identical with Y. We need one more parenthesis, right? So the mate to this is that. Right. Okay? So this says there's X and Y. They both have pierced eyebrows. They're distinct from one another. They're not identical. And if you think you found another one, you're wrong. It turns out that the one that you thought, the one that you run into is got to be this guy or that guy. So that's how we say they're exactly two girls in the class with pierced eyebrows. And we could say they're exactly three, they're at most three, they're at least three. It's basically you do the same thing, it's just that your sentence is going to get pretty long and pretty ugly. Okay? There are lots and lots of examples in the book. So make sure that you read that section of the book. All right. Yeah. Did I want to say more about that? We'll do some more examples of identity, translating with identity in a moment. But there was another thing I wanted to talk about. Now, remember when I introduced the notion of singular term? I said that a singular term is an expression that either names or purports to name just one thing. It picks out just one thing. And so examples of singular terms that we looked at were things such as Tufts University, Jana Kasab, Boston, Massachusetts. But there were also singular terms that were things like the tallest tree in the academic quad, the present king of France, which is a non-referring one. We don't have non-referring ones in PL. Our constants are not non-referring. But these expressions, the largest city in France, these expressions all have something in common, namely they start with the definite article the such and such. And this is a singular term, but it's a particular kind of singular term. It's called a definite description. And so if we add identity to our language PL, we have the means of translating sentences that have occurrences of singular terms in them. So rather than just replacing a singular term with a constant, we can actually get at more of the logical structure of a sentence that has an occurrence of a singular term. So for instance, this is something that I mentioned in the first lecture. I was going to say the first day of class, but we don't have first days of class anymore. The author of Alice in Wonderland is a logician. Interestingly. Or the unique girl in the class with a pierced eyebrow shaves her head. That's actually become a kind of popular pandemic solution to what do you do with your hair. Okay, so the girl in the class with the pierced eyebrow. I'm going to get rid of that unique. I just stuck it in there to remind you of what the definite description, what the role of the definite description is. So this is a definite description. It's a singular term. The author of Alice in Wonderland. The girl in the class with the pierced eyebrow. What this definite article does is it indicates uniqueness. The one and only author of Alice in Wonderland is a logician. So Interestingly, let's take a look at the first one. Interestingly, this sentence actually commits us to the existence of something that satisfies the definite description, the author of Alice in Wonderland. And the way in which we would translate that, let's have the universe of discourse be people, and we'll have AX means X authored. X is an author. I'll put X is an author of Alice in Wonderland, okay? And then we'll have LX mean X is a logician. And what we're going to say when we translate this sentence, we're going to pack into that sentence the idea that there's a unique author of Alice in Wonderland, and that person is a logician. So we're actually going to need an existential quantifier. It's going to be, there exists an X who is an author of Alice in Wonderland, right? So that says there's at least one author of Alice in Wonderland, but we want to say he's the only one, right? And the way that we do that, remember, is, if you run into somebody who's an author of Alice in Wonderland, no, it's the same guy. And by the way, it doesn't matter what order you put these in. I could have had this just as easily as that. Okay. Okay. So just that says there's exactly one author of Alice in Wonderland. But what we want to say is, furthermore, X is a logician. So what this says is that this says there's at least one author of Alice in Wonderland. He's the only one. And furthermore, he's a logician. So that's kind of interesting that sentences that have occurrences of definite descriptions are actually existential claims. This is actually interesting philosophically, but I'm not going to get into that right now. How would we do, just for fun, how would we do the girl in the class with the pierced eyebrow shaves her head? It would follow a very similar pattern. Let's do it in blue, though. We'd say, again, the universe of discourse is girls in the class. PX means X is a pierced eyebrow. And let's have SX mean X shaves her head. Okay? So we have, there's at least one girl in the class who has the pierced eyebrow. And if you think you found another one, you're wrong. It's the same one. And she shaves her head. Okay? Well, that's kind of interesting. So we can eliminate these definite descriptions. We can analyze the logical structure of sentences that have definite descriptions. And interestingly, they are existential claims, which might be a bit of a surprise. Okay, let me say a little bit more about identity. So, now to say that X and Y are identical, or that A and B are identical, is to say that they are the same thing. Okay? So now, if I wanted to say, for instance, Russinoff is the oldest person in the room, in the house. Actually, I'm the only person in the house right now, but let's pretend there were some younger people in the house. That would be nice. Russinoff is the oldest person. An older person is going to be arriving shortly, but for now, I'm the oldest person in the house. Russinoff is the oldest person in the house. Basically, I'm saying Russinoff is identical with the oldest person in the house. It's different from predicating being the oldest person in the house. Whoops, I left out the, which is an important part of the sentence. I'm actually saying that I, is identical with the oldest person in the house. They're the same people, right? So in PLE, PL with identity, we have the means to say, just a bunch of different things that we were unable to say without it. So for instance, let's go back to a sentence that I think we looked at in a previous lecture. Everyone helps someone. And I think we were talking about loves at the time that this came up. Everybody helps someone. If we drew our little world here, let's say let's put 4 things in it for fun. Everyone helps someone. If we have, like, our dots are the people, and the arrow coming out of a dot means that person helps the person that the arrow points to. So, like, this guy helps that guy. So everyone helps someone. You'd have to have, every dot has to have an arrow going out of it. So you could have something like that. Okay? But we also saw that this could be true in a one-membered universe of discourse. Everyone helps someone. Well, if you've only got one person in a universe of discourse, well then, if he helps himself, it's true that everybody helps someone because he's helping someone, namely himself. So how could we say everyone helps someone else? Someone other than himself. Everyone helps someone else. Well, it's not going to be for all x, there exists a y, h, x, y, because that just says everyone helps someone. And it could be that there's one thing in the universe who helps himself. Okay, so what do we have to add? For all x, there exists a y such that x helps y. And by the way, note how I don't have any parentheses around this. That was a confusion that a number of people have in the quiz, just a syntactic thing. You don't need parentheses around that. How would we say everyone helps someone else? Well, we'd say for all x, there exists a y, and x helps y, but furthermore, x and y are different guys, right? It's not the case that x is the same guy as y. So here I do need the parentheses. That was a very sloppy looking x. I do need the parentheses here because I've got a conjunction, and I need to make sure that it's clear that both of these quantifiers range over this whole sentence. So both of these occurrences of x are captured by that quantifier, and the y's are captured by that quantifier. So that's how you'd say everyone helps someone else. Everybody is such that there's someone he helps who's different from him. Okay? Let's maybe just do another one. How would we say... Any two philosophers disagree. That's not true, but sometimes it feels that way, right? Any two philosophers disagree. Well, how would we put that? Given any, let's try this, for all x and for all y, if x is so let's say the universe of discourse be people and px mean x is a philosopher, okay? If x is a philosopher and y is a philosopher, and we'll have dxy mean x disagrees with y, then x disagrees with y. Or we could have dxy means x and y disagree, okay? Okay, so does this do it? you got this philosopher, you got that philosopher, pick a philosopher, pick another philosopher, or are you picking another philosopher? Pick a philosopher, they disagree. This allows for the possibility that this kind of implies that every philosopher disagrees with himself. I'm going to switch to the feminine pronoun. Every philosopher disagrees with herself. This doesn't rule out the possibility of X and Y being the same philosopher. So what we want to say is that any two distinct philosophers disagree with one another. So we have to use identity there. We'd have to add something to this. And what do we add? We have to say that X and Y are different, that they're not the same philosopher. So we'd have to say for all X, for all Y, X is a philosopher, Y is a philosopher. They're different. They're different people. If that's the case, given any two different philosophers, then they disagree with each other. That's how you'd say it. Do you see that? Okay, well we can do some cool stuff with identity. Lots and lots of examples in the text, and also I posted in Module 9 the errata section from it's online, because as I said, the problems from section 7.4 were omitted from the textbook for some reason, but they're in the errata. But the problems for 7.5 involving identity are in the book, and the solutions are in the solution manual. The solutions to 7.4 problems are also in the solution manual. So I think I'm not going to do any more examples right now, but there was one more thing that I wanted to talk about that's in section 7.5, and that is about what they call relations. And we're going to talk about properties of relations. A relation is really just a two-place predicate. Okay? Like loves, helps, is happier than, things like that. And there are three properties of relations. One is called transitivity, and I think you've encountered these notions somewhere in math in high school. One's called transitivity, one's called symmetry, and one's called reflexivity. And I just wanted to talk about these before I end this lecture. So what does it mean to say that a relation is transitive? Here's how you would express that some relation R is transitive, where R is some two-place predicate, two-place relation. You'd say for all X, for all Y, for all Z, if X R's Y, let me make that neater. If X R's Y, X bears the relation R to Y, and Y in turn bears the relation to Z, then X bears it to Z. So I should have done this all in one line. That's how you say transitivity. And so basically you're saying, if you got this guy who bears it to that guy, and this guy bears it to that guy, well, to say that it's transitive, this guy's got to bear it to that guy. Okay? So let's just think about some relations that in English that are transitive or are not transitive. Well, identity is a transitive relation, right? If this guy is identical with this guy and this guy is identical with that guy, well, then this guy's got to be identical with that guy. Identity is, that was a weird picture. Identity is transitive. If we were together, I would ask you for some examples. Bigger than, happier than, larger than, older than, all of those linear relations are transitive. If I'm older than you and you're older than somebody else, then I'm older than that somebody else, right? So these are transitive relations. What's an example of a relation that's not transitive, where this is not the case? How about loves? Life lesson. Loves. Right? Because this guy, and I'm sure you've encountered such situations, right? You love somebody, and the person you love loves somebody, but you don't love that person, right? There's certainly no guarantee that you love all the people that the person you love loves. So loves is not, whoops, I just erased it. Loves is not transitive. Okay, and you can think about others. So that's what transitivity means. Symmetry. Symmetry, the way we'd express that R, some relation R is symmetric, is this way. For all x and for all y, if x r's y, then y r's them right back. Right? So given any things, if one thing r's the other, then the other r's the one. Right? And there are lots and lots of examples of relations that are symmetric as well. Identity is symmetric. Sibling is symmetric, right? So a symmetric relation looks like that, right? You got a double arrow going here. Like if this person's your sibling, then you're that person's sibling. What is an example of a relation that's not symmetric? Is a parent of, right? So if this guy is the parent of that guy, well, this guy isn't the parent back, right? So being a parent is not symmetric. How about loves? Is love symmetric? I imagine you're aware of the fact that it's not, maybe not. I hate to be the one to tell you, but sometimes you can love somebody, but that person doesn't love you back, right? Okay, so that's an example of a relation that's not symmetric. Okay, finally, reflexivity. What does it mean to say that R, some two-place relation R, is reflexive? It means that everything in the universe bears the relation to itself. Everything in the universe bears the relation to itself. So what would be some examples of a reflexive relation? Identity. Again, right? Everything's self-identical. Is the same age as. Is the same height as. All of these are, like everybody's the same height as themselves, right? All of these are reflexive. How about relations that are not reflexive? Well, not everybody loves themselves, right? You might know, like there might be situations where, you got people who don't love themselves. You're not your own parent, right? Nope, that doesn't work. Sometimes you're not your own friend, sadly. Is older than is not reflexive. You can't be older than yourself. Sometimes it feels like I'm older than myself, but I know I can't be older than myself. Okay, so that's another thing that's discussed in that last section of the chapter. So transitivity, symmetry, and reflexivity, and there's some exercises following the section where they kind of drill you on thinking about these properties. So I'm going to stop here, and I'm going to give some thought as to whether I'm going to move on this week to talk a little bit about the semantics of the language, or whether this is enough material. So I'm going to think about that as I watch the election returns. So we'll see. I hope everybody's doing well. I know this is it's a week where there's a fair amount of worry, anxiety, anticipation, uncertainty, but logic helps with that. I mean, it's a good thing to do. You can sometimes just sort of carrying on and doing what you need to do is the best way to handle difficult situations. And logic is clean, and it's a way to escape difficulties too. Okay, so I'm going to sign off for now.